Hi, we have AP Physics 1 past paper 2022. We are discussing free response question section. In question 3, which carry the 12 point, a wheel is mounted on a horizontal axle. A light string is attached to the wheel rim and wrapped around it several times. And the small block is attached to the free end of the string as shown in the figure. When a block is released from the rest and begins to fall, the wheel begins to rotate with negligible friction. Okay. The two students discussing how different form of energy changes as the block fall. One student say kinetic energy of the block increases as it falls. The other student say because the gravitational potential energy is converted into kinetic energy, the student decided to test whether decrease in gravitational potential energy is equal to the increase in block kinetic energy of the block start moving after immediately before it reaches the ground. Now we have to design the experiment a procedure that student could use to compare the increase the block translational kinetic energy with decrease in gravitational potential energy of the block earth system as the block fall. In the block in the table, list the quantities that would be measured in your experiment, define the symbol of each quantity and list the equipment that could be used to measure each quantity. You don't need to fill every row. If you need to additional row, you may add them space below the table. If the space to the right of the table describe overall procedure, provide enough details so that another student could replicate the experiment, including any step necessary to reduce the experimental uncertainty. As needed, use the symbol, define the table. If you need, you may include simple diagram of the setup of with your experiment procedure. Now, first of all, we have to define the things. First, we have the mass of the falling block. It is the MB. So we can measure the mass of the block using the mass balance, electronic balance, or distance of the block fall. We represent it with D. We can measure the distance with the meter stick. Time to take the fall. How much time the block take to time reach the ground. It is a time t. We can use the stopwatch to measure the time. Now, what is the procedure? Procedure set up the wheel string as shown in a picture. As this is a fig, decided the wheel with the block. So the measure the mass of the block using the scale as we described the mass balance. Measure the height from the floor to the block starting point using the meter stick. Now hold the block at starting point, release it from rest. So there is no initial kinetic energy. Use the stopwatch to time how long does it take to block to travel the distance. Repeat the several time at same starting distance. Take the average time to reduce error from human reaction time. Okay, this is the step one. Now repeat for all different starting distance. Mean all we have to repeat with the different starting position to make different time. Now, explain how student could determine the kinetic energy of the block immediately before it reaches the ground, the floor, using the quantity you indicated in a table part A. First of all, S is equal to VIT plus half AT square because initial velocity is zero because the starting from the rest. So D is the distance travel half GT squared. So we can measure the G 2D by T square. Now, what is the Vf is equal to Vi plus At? Again, initial velocity is the zero. G value of the G can be placed here. So we can measure the final velocity, which is V2D by T. So D we have to measure, T we have to measure, which we can conclude the final velocity of the block just before reaching the ground. After that, kinetic energy of the block is 1 by 2 mv square. We can be used here 2 md square by T square. So mass, distance and the time, three quantities as we indicated in the table can be used to measure the kinetic energy of the block. Okay, the graph above represents both change in gravitational potential energy of the block wheel earth system and the translational kinetic energy gained by the block as a function of block falling the distance t. On a graph, draw the line or the curve to represent rotational kinetic energy of the wheel as a function of the block falling through the distance t. Okay, the mechanical energy is conserved, no friction is there, the total energy change is zero. So loss in potential energy should be equal to gain in translational energy and gain in rotational energy of the wheel. So gain in the rotational energy of the wheel can be calculated by the, we can move the translational kinetic energy to other side with the negative sign. So there is a difference between two potential energy and translational energy is equal to the rotational kinetic energy of the wheel. So let's say we take the value of this line. There is the value of the -3 gravitational potential energy, and the kinetic energy of the block is the 0.1. So there is a kinetic energy rotational is the difference of these two. So that is equal to 0.2 joule. So that's the answer. It is asking the rotational kinetic energy as a function of time. So this is the answer. Now, the student also measures the angular velocity of the omega of the wheel as the block falls and determine the rotational kinetic energy of the wheel. Student then make the graph Kr as the function of omega square. Here is the graph, given points are given. On the above graph, draw the straight line as best represent the data. So here is the line that connect the maximum 4 points on the line. So we can calculate the slope. So slope of the graph can be calculated delta y over delta x, delta kr by delta omega square. We can calculate the difference from these two. So, we take arbitrary 2 points for change in kinetic energy rotational and change in angular velocity, square of the angular velocity. So the answer is 0.026 kg per meter square. That's the slope of the given graph. With the given straight line, the green line, it is asked the straight line. Now, what use the line to draw the part 1, calculate the experimental value of rotational inertia of the wheel. The rotational inertia is equal to 1 by 2 I omega square, I omega square. So we can calculate I omega can be moved to the other side. So in bracket kinetic energy rotational over omega square, we have the value of these point. We place the value of this. The answer is rotational kinetic energy is 0.052 kg per meter into meter square. So that's the answer. If you have any query, kindly ask in the comments. If you like the content, kindly subscribe and share it with your friends. Okay, take care.